same thing as yesterday, but in addition to that, we're also thinking about shading, and we're thinking about if our graph should be a solid or dotted line. So when you are graphing inequalities, you have a boundary line and a shaded region. The boundary line is either dotted or solid. Those are our only two options. And it depends on the symbol. So it's dotted if it's greater than or less than. It's solid when we have the equal sign as well. So solids are when we have the equal sign. That tells us it's included in the solution region. And then we need to check where to shade and see whether our statement is true or false. If a statement is true, then we shade in that region. If a statement is false, then we shade in the other region. And we'll do one of those in a minute to really see what that means. So it's kind of hard sometimes just to think about it in words, like it's easier to actually like kind of jump in and do it. Alright, the first two are the easiest type. These are the type where you don't have both an X and a Y. What type of line do I have in part A? Horizontal. And where does my horizontal line live? -9. Now, before I draw it in, remember we gotta think solid or dotted. What does this tell me? Solid or dotted?
Solid.
Solid. Okay. So I'm gonna draw my horizontal line at -9, and I drew it in as a solid. Alright. We are looking for values where y is smaller than or equal to -9. Are the values here in terms of y smaller than or equal to -9? Are the values down here smaller than? So notice that your line is going to divide your graph into two regions. And you're going to need to figure out which region to shade. So remember what the solution means. Because I feel like when I was in school, I remember doing these and I was like, I draw the line and then I shade. But if you asked me what this was, I'd be like, well, it's my answer. But I didn't really understand what it was. So what this means is that any ordered pair, any point that lives down here will satisfy this. So think about if I picked a random point at -10, +2, is -10 smaller than -9? If I plug it in? Yeah. So any of those should be a solution. And I don't find test points when they're horizontal and vertical lines. I kind of am by like thinking about where it should live. But again, I don't truly plug in a test point like I'm going to in a minute when we get to the oblique lines. Alright, x equals is what type of line? Vertical. And this one's going to be at?
-4.
And careful before I draw it, solid or dotted? Dotted. And I already regret my life choices because I made that other line without my straight edge. Again, if you want a straight edge because you're a little type A like I am, go grab one. Thank you. We just started with notes. Alright, so here's my graph and now I've got a shade. Again, I don't really do a test point here. This is just kind of like you can look at it and think logically. Where are my x values that are bigger than -4? Are these x values bigger than -4? Are these? Yes. So we're going to shade. So that is going to be my solution region. So the dotted line tells me these aren't solutions, but everything beyond it is a solution. So you're shading where the answers live. Again, I always try to explain what it is because I feel like sometimes in school I did the things because I was told to do the things, but I didn't always understand why or what it meant. And so I want to make sure I share that with you as much as possible, the why and the what it means. Alright, when you're ready, flip the page. They get a little bit trickier, but not much. And we only have 2 more examples today, like we are not heavy on examples. Alright, so we need a graph, which is why we started out graphing linear equations yesterday. We're carrying that over to today. I'm gonna write myself a note first, cause this is what I'm bad at. I'm gonna write solid, 'cause I always forget, and this one is gonna be dotted. So I like to write myself little reminder notes, because otherwise I just draw a solid line, cause that's what we always do, right? So I like to write myself little reminder notes. This one's solid, why? Because of the equal to under, and this one is dotted because there's no equal to under. So that's the first thing I think about. Okay, let's graph, like what we did in the warm-up and what we did yesterday. My y-intercept lives at 1, so I'm gonna graph a point at 1. What's my slope? 1. And remember, we wanna think of our slope as a fraction, so I'm gonna put it 1 over 1, cause that's still 1. And so remember that this is my rise, and this is my run. So I'm gonna rise up 1, run over 1, rise up 1, run over 1. And if I'm having a moment where I wanna be defiant, I'd rather do the opposite. Can I fall down 1 and go left 1? Yeah. So you can do the opposite of both and it still works. Alright, solid line. We wrote ourselves a note already. Solid line for this one. Alright, now this one I actually am gonna pick a test point. My favorite test point to pick is the origin, because is there anything easier to plug in than 0? Yeah, I think 0 is the easiest. So this is my test point right here, and I'm gonna plug it in. So here's how we plug in our test point. I'm gonna plug in 0 for x, and I'm gonna plug in 0 for y. The only time I can't use this test point is if my line goes through it. So let's talk about that rule for a minute. You can pick any point as a test point, but you can't pick anything on the line. Okay, so don't pick on the line. You can pick anything down here, anything up here, whatever you want. Okay? Doesn't matter what you pick, but it can't be on the line. Alright, so I'm gonna plug in 0 for y, and I'm gonna plug in 0 for x, because that's the test point I picked. So I went back to my original equation, and I plugged in 0 for y, 0 for x. And I'm gonna see if this gives me a true or a false statement. So I get 0 is less than or equal to, what is 0 plus 1? 1. Is 0 smaller than or equal to 1? Yes. So that is a true statement. If it's true, you shade where the test point lives. So the test point lived here, so I'm gonna shade here. Had it been false, like let's say it came up with a statement that said 0 is less than or equal to -5. So if it gave me a false statement, then I would have shaded in the opposite. Okay, so that's our steps. Now, these are worth more points to me on a quiz or a test, because think about the different pieces you've got here. You've got the graph of the line, you have to decide solid or dotted, and then you've got the shading. So these are worth a few more points for me, so they're kind of bigger ticket problems. Alright, part B, what's my y-intercept? -3. What's my slope?
2.
Yes, it's 2, and we're gonna put it over 1, so that I can think about it truly as my rise over, oh, you can't do that. So I can truly think of it as my rise over my run. So I'm gonna start at my y-intercept, that's my starting spot, and I'm gonna use my slope as directions to get to other points. So rise 2, run 1, rise 2, run 1. Okay. Dotted line. We're so used to making solid lines. This is the spot where I screw up a lot, and I've had a lot of people over the years draw theirs in solid and then write themselves a note, whoopsie, it should have been dotted. You won't be the first or the last to do that. So make sure you're trying to pay attention there to which one you need. Alright, I'm gonna pick a different test point this time, because 0, 0 isn't always an option, so I'm gonna pretend like it's not an option. Do you see how it is an option? Do you agree with me? Like I could use it? Okay, I'm gonna pretend it's not an option just to show you that you can pick any point you wanna pick. So, I'm gonna actually pick something down here. I'm gonna pick 4, -1. I'm gonna make this my test point. Kind of a weird test point to pick, but that's what I want. 4, -1. So again, you can pick any point on the graph. There are infinitely many points on this graph. So you can pick anything you want. This is the one I chose this time. So I'm gonna go to my equation and I'm gonna plug it in. So remember, this is x, this is y. So I'm gonna sub in my -1. -1 is greater than 2 times x. What's my x for my test point? 4. Yeah, so 2 times 4 minus 3. So again, I'm just subbing in the x and y I picked into the equation to see if it works. So I get -1 is greater than 2 times 4 is 8. 8 minus 3?
5.
5. Okay, let's look at our statement. Is -1 bigger than 5? No, that is false. So should I shade where the test point lived? No, I should not. I should shade in the opposite area. So the test point did not work, so I'm going to shade on the opposite part of my graph. Again, I don't care if you choose 0, 0 every time. I just wanted to show you it was possible to pick another one. Okay, so that way if you encounter one on the homework tonight where you can't pick 0, 0, I don't want you to feel like, but I didn't see an example of that. Yes?
Why do you have to do the test point? The equation says it right there. That y is greater than.
So we always want to double check because sometimes when the slopes get more extreme, it's hard to tell. And so especially also when we get into harder equations where they are quadratic or cubic, it's a good process to get in to use the test point because you can't always tell. Does that make sense? So it's always better to double check. It's like being just extra safe. Yes. Great.
I did 0, 0 as my test point for that one.
Yeah.
And I got 0 is greater than -3.
Is 0 greater than -3?
Yeah.
So that's true.
Oh, my bad.
So it is true, so you should have shaded there. Yeah, you did it right. Perfect. So again, whatever test point you pick, it's still gonna work. You don't have to pick the same one. Again, there are infinitely many points on the graph, so we're not gonna pick the same test points as each other. It's just not gonna happen. Alright, page 43, unless we all love 0, 0, in which case maybe we will. Alright, page 43, you're gonna need graphs again. If you want the graphing paper, it's back there. If you want the graphing post-it notes, they're up here. And if you just want to write it on your notebook paper, you have notebook paper, or there's some back there. So, page 43, 19 through 28, I'm going to put my book under the board, or under the doc cam. Under the board wouldn't help. I'm going to put my book under the doc cam. If you would rather use your own book or get onto the online textbook, either of those is a fine option. If you are struggling with anything, ask. That's why I'm giving you time to start stuff in class, so that you can ask me and get any help that you need. Right? That is the purpose of the class time. So you don't get home and end up in a, you can go back there if you're gonna work. So you don't get home and end up in a situation. Alright, so we are doing 19 to 28. Can I put my book in? You guys got it written down? And it's also on the back board if you forget the problem numbers. Here we go. Here's the homework. So 19 through 28. So it starts a little bit easier, gets trickier. If there are any you need help on,